Hello students. In our previous video we studied about the chapter 5, that is the periodic table. Okay, and today we will start with the elaborated study of this. See, the first one is classification by early chemists. How they classified the then known elements. Yes, basis of the classification of elements. Early chemists, they arranged the elements according to their properties, their valencies, and their metallic and non-metallic character. Okay, this you have to learn. Their properties, if their properties are similar, then they were arranged together. If their valencies were similar, elements having similar valencies were placed together, and they were also placed according to their metallic and non-metallic character. Now, the above method of classification was discarded since elements behave both as metals and non-metals. They show metallic and non-metallic nature and have variable valencies. See, this was not possible to arrange all the elements according to this property, and this theory or this classification was discarded. Atomic weight and not properties were considered for further classification. After this, after this classification, atomic weight was considered and not the properties. Now, whatever we will study now, three classifications we will study, like Dobereiner's law of triad, Newlands law of octaves, and one more is there, that is Mendeleev's periodic classification. These three classifications we will study, where the elements were arranged according to their increasing atomic weight. Yes. Now see, basis of classification of elements. Dobereiner's triads. This thing I told you yesterday also, that Dobereiner, he arranged elements in increasing order of atomic weight. Increasing order of atomic weight in group of 3, and those 3 groups, they were called triads. See, one more thing is there, it is clearly given here. Chemically analogous elements arranged in increasing order of their atomic weights. Those elements which have similar chemical properties, they were arranged according to their increasing atomic weights, and they form a group of 3. That group of 3, 1, 2, 3, it is called a triad, in which the atomic weight of the middle, the atomic weight of this sodium here, which is 23 here, this atomic weight was found to be generally the average of these two, or the arithmetic mean of these two. When these two were added and they were divided by 2, the digit which was coming by taking out the arithmetic mean of these two, this mass was roughly equal to that mass. Okay, so this was the law of triad, where the elements or the then known elements, they were arranged according to their increasing atomic weights in a group of 3, where the arithmetic mean of the first and the third elements was found to be roughly equal to the weight of the middle element. So this was the Dobereiner's law of triad. And again, see here, what they have given, the atomic weight of sodium is the average mean of lithium and potassium. Now this method was also because disordered collection of elements was there, not holding true for all the then known elements, because so many elements were discovered by that time, but it was, this law was not holding correct for all the elements which were discovered till that by that time, and the properties of elements grouped into triad were not found to be similar. Elements were arranged according to the increasing atomic masses, but their properties of those elements which were put in a triad, their properties were not similar, or they were not matching with each other. Here it is correct. If we talk about this one, this was the correct one. That's why this is given you as an example. Now the second law, it's of Newlands. Newlands was the scientist. Newlands law of octaves. Octaves like musical note, he said. See, Newland arranged elements in increasing order of atomic weights. Again, atomic weights in series of 8. He arranged the elements in series of 8. Where see 1, 2, 3, 4, 5, 6, 7, again 8. So the property of lithium and sodium, it was found to be similar. If we are talking, suppose we are talking about carbon, 1, 2, 3, 4, 5, 6, 7, 8. It means the properties of these two were found to be similar. Yes, we know that carbon and silicon, they have similar properties because both are having valence electrons 4. But again, some problem was there that we will study later. But first we will study this, the law of Newlands. Elements, when arranged in increasing order of their atomic weights, show resemblance in physical and chemical properties. Their physical and chemical properties were found to be similar between the 8th element and the first element. The property of the first element and the 8th element, it was found to be similar to the 8th and first notes on a musical scale. Like this thing I've told you earlier also, like in musical notes, it's sa, re, ga, ma, pa, dha, ni, and again sa. First and 8th notes are similar in a similar way. The properties of the first and the 8th element were found to be similar. The 8th element from lithium is sodium, and from fluorine, if we are talking about fluorine, see 1, 2, 3, 4, 5, 6, 7, and 8. So the properties of fluorine and chlorine, they were also showing the similar properties. Now method showed odd grouping and failed. The grouping was not proper for all the elements, to leave spaces for undiscovered elements. If suppose any undiscovered element is there, it's proper for that undiscovered element, the places were not there. Method of classification, it showed meaning with the light elements only. See, this was applicable till calcium, that is atomic mass 40 only, and for the rest elements it was not applicable, but failed with the heavy metals beyond potassium, it is given here. After that it was not found to be proper. So this was about Dobereiner's law of triads and Newland's law of octaves, and in our next video we will study about Mendeleev's contribution or Mendeleev's classification. Thank you.